This number is the least common multiple of all natural numbers from 1 to 113. This means that every natural number from 1 to 113 divides this number, and there isn't a smaller positive integer with this property. Define a function psi of x as a log of the least common multiple from 1 to x. Psi is called the second Chebyshev function. In this video, we'll talk about how psi reveals the distribution of prime powers and how this mega number plays a role in bounding psi. The least common multiple up to x is equal to the product of p raised to the k, where p is prime and p raised to the k is less than x. In psi notation, that would be psi of x equals the sum of k times the log of p, where p is prime and k is the maximum exponent. K is sometimes called the p-adic valuation. We can see this for our mega number if we write down its prime factorization. It is equal to 2 raised to the 6 times 3 raised to the 4th times 5 squared times 7 squared times all the other primes up to 113. We can also create a recursive formula for the least common multiple. The least common multiple of 1 to x plus 1 is equal to the least common multiple of x plus 1 and the least common multiple of 1 to x. If you want to use psi notation, this becomes psi of x plus 1 is equal to the log of the least common multiple of x plus 1 and e raised to the psi of x. These formulas show that the least common multiple up to x will only increase when x is a prime power. Here's a graph of psi of x. It is very close to y equals x. If we zoom out more, psi of x and x become nearly indistinguishable for large values. It can be shown that the prime number theorem is equivalent to showing that the limit as x goes to infinity of the ratio psi of x divided by x equals 1. Here's a graph of that ratio. This mega number comes in when we try to find an upper bound for the ratio psi of x over x. We know that eventually it will approach 1 because of the prime number theorem, but is there a constant c that the ratio never exceeds? In their paper, Approximate Formulas for Some Functions of Prime Numbers, Rosser and Schoenfeld proved that x equals 113 maximizes the ratio of psi of x over x. They calculated values for this ratio up to 2000, and then were able to show that it never gets any larger. The constant that they calculated is psi of 113 divided by 113, which equals 1.03882. Therefore, we can say that psi of x is less than 1.03883x. Why do we care about that? Well, there are many different types of approximations that have their own uses. Number theorists use approximations of prime functions to prove properties of prime numbers. Approximations can tell you that we will always be able to find prime numbers that are within 70 million of each other. Another application is that you can use approximations to make claims like more than 5/12ths of the zeros of the Riemann zeta function lie on the critical line. This number is the least common multiple of 1 up to 113. I thought this number was cool because it can be easily stated using the least common multiple, but it also says something about prime counting functions. Thanks for watching my video.